Hi, good morning everyone. Today I would like to share with you a new topic that is the Fourier transform property. The first property is the linearity. And this is the formula for this. So Fourier transform of a1x1t plus a2x2t is equal to a1x1 omega plus a2 x2 omega. So this is the formula for the linearity. Okay, so let's look at the example. Okay, given the xt equal to exponent negative at ut and x omega equal to Fourier transform xt equivalent to 1 over a plus j omega. So find the Fourier transform of 2 exponent negative 2t ut plus exponent negative 3t ut. Okay, so you need to find the Fourier transform. Okay, if you look at this one, the Fourier transform of the xt is like this. And this is the xt. The Fourier transform of xt is 1 over a plus j omega. So what is the is it same with this one? We have this one, right? If you have the exponent negative at, so means that the a here is what? The a here is 2. And do we have extra of 2 here? So when you write the x omega, that is x omega equal to 2. 2 is referred to these 2. Okay? And then divide by 2 plus j omega, because the a here is equal to 2. Okay, and then plus with, okay, exponent negative 3t ut. If you compare with this one, we have the a is referred to 3. So 1 over 3 plus j omega. So this is the answer. Okay, next we look at the time scaling. The second property, we look at the time scaling. And we have the Fourier transform of xat equivalent to 1 over modulus a x omega over a. Okay. So example 2. Okay, given the xt is equal to exponent negative 2t ut and find the Fourier transform of the xt over 2. Okay, in this case, what is, if you compare with this one, what is the a here? The value of a is 1 over 2, right? So 1 over 2. So now we do xt over 2 is equivalent to 1 over, the a is 0.5 modulus, and then x omega. You know that the x omega is the Fourier transform of xt, right? And then the xt from the previous answer is, previous question is 1 over 2 plus j omega. So based on this one, we perform the x omega here. Okay, so you look at here, x omega over 2. Okay, x omega over 2. If you have x omega over 2, this means that x omega over a. Sorry. Okay, so it's 1 over 0.5. Okay, so this x omega is referred to 1 over 2 plus j omega, right? Supposedly we copy from this 1 over 2 plus j omega. But now it said that the omega here, okay, I highlight it, the omega here is referred to omega over a. So means that this one we also need to substitute with omega over a. Okay. So we do it as omega over 0.5 because A is 0.5. So now what do we have? So 1 over 0.5 we get 2, and then 2 plus 2j omega. Okay, do you get it? Okay, second example, we have x to t. If x to t, this means that the a here is 2. So we have 1 over a, so a is 2. And then x omega, so this means that we have 1 over 2 plus j. 2 plus j, what? Omega over 2, right? Just now is omega over 0.5. Now it's omega over 2. So now this is 1 over 2. And then this one, if we make the numerator and make the denominator as the same. So we got 2 over 4 plus j omega. Okay, because this part 2, this one you have 2 plus j omega. So 2 times 2 you get 4. So 4 plus j omega over 2. So you take up you bring the 2 to the up. So you get 2 over 4 plus j omega. Do you understand, class? Okay, now we shift to the time shifting, the third property. That is time shifting. And then we have this one. The property is Fourier transform of x t minus t naught u t minus t naught equivalent to exponent minus j omega t naught x omega. Okay, so we have this one. Then let's look at the example. Okay, example 3. Given the xt is equal to the exponent negative 2t ut, and the x omega is 1 over 2 plus j omega. So find the Fourier transform of xt minus 2. That is the shifting t minus 2. Okay, we know that from the formula. Okay, from the formula, xt minus t naught ut minus t naught equal to exponent negative j omega t naught x omega. Okay, so we do it from here. Just now this one. So xt minus 2, if we change it, that means the exponent negative 2 t minus t naught lah, t minus 2, so t naught u t minus 2. And this equivalent to what? Okay, you refer to the formula again, the property again. It's referred to the exponent j omega t naught. So j exponent minus j omega t naught. We know that the t naught is 2. So exponent minus j omega 2. So we get exponent minus j omega 2. And then we have what? X omega. So x omega is this one, 1 over 2 plus j omega. Okay, this is the answer. What about if we have x t plus 2? Okay, if t plus 2, this one we get negative 2, t plus 2, then u t plus 2. And then here we get exponent j omega. Okay, exponent j omega 2. Then this one is 1 over 2 plus j omega. Next, shall we look at the next question? X 2t minus 2. Okay, if 2t minus 2, we can factor it out into x 2t minus 1. Okay, So what is this? It's a combination of two. It means that one is shift, another one is the scaling, time shifting and time scaling. So it's time shifting, we get t minus 1. And then we have exponent j omega x omega. So this is the property for the shifting. And then we have a scaling, so x 2t. For the x 2t, we have half, okay, because the a is 2, so 1 over 2, x omega over 2. So if we combine it, if combine both shifting and scaling, we must combine both property. Okay, what I mean here is, okay, now if you look at this one, we copy down the exponent j omega. Also, we copy down the half and just left the x omega. So for the latest x omega is x omega over 2. So we have 1 over 2 plus j omega, right, usually. So if we use this one is omega over 2. So j omega over 2. Okay, just as simple as this. Okay, next we look at another question. That is exponent negative 2t ut minus ut minus 2. Okay, so we multiply in, we get exponent negative 2t ut minus exponent negative 2t ut minus 2. Okay, so let's look at if you have this one, exponent negative 2t ut, what do you get? This is what do you get here? Okay, so you get as 1 over 2 plus j omega, right? The 2 is referred to this one. Okay, now what if the shifting? X t minus 2 ut minus 2. What about this one? Do you still remember this one is what? Yes, we have 1 over 2 plus j omega. Okay, and then exponent minus j omega over 2. Okay, this part is from the formula. This one is from the formula of the time shifting. Okay, now back to your question, you have exponent negative 2t ut minus 2, right? Okay, so if we convert this one into the exponent, so you have what? Exponent negative 2t minus 2 ut minus 2. And then what do you get? That one is exponent negative j omega 2 over 2 plus j omega. Okay, so based on this one, so we continue. Another step is exponent negative 2t plus 4. We multiply in. Okay, we multiply in. Then we get exponent negative 2t, exponent 4, and then ut minus 2 is equal to this one. Actually, we just rewrite only. There's nothing much about this. Okay, why I do like this? Because if you based on your question, it's referred to the exponent negative 2t ut minus 2, and yet what you have is exponent negative 2t exponent 4 ut minus 2. Okay, so where is the extra? Where is the extra? Extra is this part, right? Apart from that, this is the same as the given question. So this is important. So exponent negative 2t ut minus 2, and then we bring the exponent 4 to the right hand side, so we will have exponent negative 4 exponent negative j omega 2 over 2 plus j omega. Okay, we bring the exponent 4 to the right hand side. So now the exponent negative 2t ut minus exponent negative 2t ut minus 2 is equivalent to 1 over 2 plus j omega, the first one, minus with the second one, exponent negative 4 exponent j omega 2 over 2 plus j omega. So if you want to factorize it out, because we have same denominator, we factorize it. Okay, so this is the answer after you factorize it. Okay, do you understand for this one? Okay, if you understand, we move to the next properties. That is the frequency shifting. For frequency shifting, you have this one property: Fourier transform of exponent j omega naught t xt equivalent to x omega minus omega naught. Okay, let's look at the example. Okay, for example, given the xt equal to exponent negative 2t ut and x omega is equal to 1 over 2 plus j omega, we use the same equation. And then find the Fourier transform of the exponent j20t xt. So what is the answer? If you, based on the property, you will get x omega minus omega naught, right? X omega minus x omega minus omega naught. So means that the omega will change to omega naught. So now the answer is, you will get 1 over 2 plus j omega minus omega naught. So the omega naught of this case is what? 20. So this 20 is the omega naught. Okay? Okay, another question. If you have an exponent j20t, x 2t minus 2. If exponent 20t xt, you get 1 over 2 plus j omega minus 20, like I told you just now, like in the example A. And what about x 2t minus 2? Okay, example, exponent 2t minus 2, also based on the previous question, you will get exponent minus j omega multiply with half multiply with 1 over 2 plus j omega over 2. Okay, so this is exactly from the previous question. Okay, this one. And then, okay, now you have the exponent j20t x 2t minus 2. So you will get this one. So for the last one, you will combine everything. What do you mean by combine everything? You have this one, right? So you write out this one. And also you have this one. And the x omega is the j omega minus 20. And also you have the 2 here, divided by 2. So for easiness, that one is 2 plus j omega minus 20 over 2. So you include everything. Okay? Do you understand, class? Now next look at the another property, that is the modulation. For modulation, we have the property like this. Fourier transform of the cos omega naught t equal to the half x omega minus omega naught plus x omega plus omega naught. So this is the property. Okay, now let's look at the example. Okay, given that xt is equal to the exponent negative 2t ut and x omega is again is 1 over 2 plus j omega. So you need to find the Fourier transform of cos omega t xt. So cos omega naught t xt is equivalent to, based on the formula, is half of the x omega. So x omega is referred to the 1 over 2 plus j omega, right? So 2 plus j omega minus omega naught plus 2 plus j omega plus omega naught. Okay, is it simple? Now we go to another example again. Cos omega naught t and then x t over 2. What will be the answer? Okay, as you have done before, xt over 2, you get what? 2 over 2 plus j 2 omega. Okay, then what about the cos? Cos omega dot t x t over 2. So you get half. So it's from the cos, you get half. 2 over 2 plus j 2 omega. So omega change to omega minus omega naught. And we repeat the same things. And then you simplify, you cancel out this one. So you get just 1. Okay, so this is the answer. It's quite simple. Now we go to another example again. Okay, another example is like this. Xt equal to rectangular t over 4. And now, okay, x omega is 4 sin 2 omega. So you need to find the xt cos 10t. So from previous question, we know that from the question we know that as xt is rectangular t over 4, and then we get 4 sin 2 omega. So what about the cos 10t xt? That is equivalent to, for the cos you have half x omega minus omega naught, right? Omega naught is referred to 10 because cos 10t, so it's 10 plus x omega plus 10. So x omega, what do you get? X omega is 4 sin 2 omega. So you copy down the original one, this one, and you don't forget you have the 4 sin 2 omega. So you have multiply with 4 sin omega, 2 omega, 2 omega. But this omega you will have to minus with 10. Substitute with 10. Okay, you have 2 here. So I have half, oh sorry. So I cancel, I get 2. So 2 sin 2 omega minus 2. 2 omega minus 10 in bracket plus 2 sin 2 omega plus 10. Okay? Okay class, now let's look at another example. If x1t equal to 2 cos 200 pi t and x2t equal to 5 cos 1000 pi t, if Fourier transform of yt equal to x1t, x2t using the frequency shifting property of Fourier transform. Okay, now how to going to solve it? So yt equal to the xt, x1t, x2t, correct? Okay, now your x1t is what? 2 cos 200 pi t. And your x2t is 5 cos 1000 pi t. So this one. So this one you can combine. 2 times 5 is 10 cos 200 pi t. And then cos 1000 pi t. Okay. If you refer to a property, you will have property like this. Cos omega naught t xt is referred to the half of the x omega minus omega naught plus x omega plus omega naught. So this is the modulation property, right? This is the modulation property. Okay, if you look at this one, if you compare this one with this one, so the xt is referred to what? Okay, if you compare both, you actually can see that the xt is referred to this part. So we assume this part is xt. Now, cos 1000 pi t is equivalent, the Fourier transform of cos 1000 pi t is equivalent to pi delta omega plus 1000 pi t plus delta omega minus 1000 pi t. Then we can continue. Okay, we continue. So we have 10 we have 10 and then we have to combine both. So 10 you combine, this is 10 and we combine with the half. And then because that one is 10 cos, cos is referred to this part, right? Cos is pi. Okay, maybe I should read like this. Wait. Okay, I do it this way first. So 10 cos 200 pi t. So we have 10, and then cos 100 pi t we have pi delta omega plus 1000 pi t. Okay, and then so don't forget you have the 200 here, so you have minus 200 pi t, and then plus delta pi delta, okay, pi delta omega minus 1000 pi t minus 200 pi t. So actually this is a combination of two. So cos 1000 pi t, so cos 1000 pi t you have omega plus 1000 pi t, so this part, okay, and then for the 200 part here is minus 200, okay, so that one is follow the property, that one is follow the property of the modulation. You see that the modulation property, omega minus omega naught, okay. Okay, so what else? Just now you have this part done. You still have one half, so you have to multiply with the half here. Okay. Okay, so done or not? Not yet, right? This is just the first part. You still have the second part. So it's plus with the pi delta omega plus 1000 pi t plus 200 pi t. So this is for the plus. Okay, for the plus. And then plus with pi delta omega minus 1000 pi t plus 200 pi t. Okay, so if you simplify for this one, so this one too is 5, so you get 5 pi delta omega 1000 minus 200, you get 800 pi t plus pi delta omega minus 1002 pi t plus pi delta omega plus 1002 pi t plus pi delta omega minus 800 pi t. Okay, do you understand? Alright, if you have no question from here, we can proceed to the next. That is the time differential properties. Okay, time differentiation property. Yeah, here is a property. Fourier transform of d over dt xt equal to j omega x omega. Okay. Now let's look at the example. Okay, given the xt is equal to the exponent negative 2t ut, and this is the x omega is 1 over 2 plus j omega. And find the Fourier transform of the d over dt xt. So as the time differential property, you have the formula like this: delta n over dt xt is equivalent to j omega power of n x omega. Okay. Now, if d over dt means that the order of the differentiation is 1, so n is equal to 1. Okay, first order only. So d over dt xt, which is equivalent to j omega power of 1. Then this is 1 over 2 plus j omega. Okay. Okay, the second question, find the Fourier transform of the signal given below using the time differentiation property. So you have this kind of signal, the xt. If from negative 2 to negative 1, you have the amplitude of 1, and from 1 to 2, you have amplitude of negative 1. So find the differentiation of this xt using the differentiation. Find the Fourier transform of this xt using the differentiation property. Okay, so now the differentiation of xt equivalent to differentiate 1 equal to what? You have the xt, right? You have the xt here. You differentiate the xt, you get delta t. Okay, from negative 2 to negative 1. And then you differentiate negative 1, you get negative delta t. So this is the answer. And then if you want to write in the form of the unit impulse function, you can get u delta t plus 2, okay, minus delta t plus 1. Okay, minus delta t minus 1 plus delta t minus 2. Okay, so this is the written in terms of unit step function. If you want to write in the term of j omega, so you will have the j omega x omega is equivalent to the exponent 2j omega j minus this one is the exponent j omega, and then this one is minus exponent minus j omega plus exponent minus j 2 omega for this part. Okay, and then you rearrange. You write j 2 omega plus exponent minus j 2 omega and then minus exponent j omega. Okay, and then this one is negative, so you have plus exponent minus j omega. Okay, if you look at this one, the Euler formula like this, you can guess this could be the change to cos. But if you change to cos, you might need to divide by 2. Do you still remember the cos? You divide by 2. So divide by 2, then now I time with 2 over 2. If I cancel out, I can just remain the same value. So if I have 2 here, so I can change to cos. So exponent j2 omega plus exponent minus j2 omega divided by 2, we change to cos. Okay, it changed to cos 2 omega. And then this part. So I have minus. Okay, minus is from here, minus. So this one, exponent j theta plus exponent minus j omega divided by 2. This one I can change to cos omega. And the remaining 2 is times 2. So 2 like this. So what is the answer for x omega? So I bring the j omega to the right hand side. So 2 cos 2 omega minus cos omega divided by j omega. Okay, class, understand? So this is the first example of time differentiation. I can give you another one for the differentiation also. Now, let's look at another example. Okay, class, let's look at this example. Use the time differentiation property of the Fourier transform to solve the Fourier transform of the xt. So xt equal to 2t plus 8 is from negative 4 to negative 3. Okay, it's referred to this one. And negative 2t, negative 4 is referred to this one. It's from negative 3 to negative 2. And 2t minus 4 is from 2 to 3. Whereas for 3 to 4, okay, this from 3 to 4, I have negative 2t minus 8. Okay. If you draw the signal st, you may get this figure. Okay, you may get this figure. Okay, so the question asks you to find the time differentiation property. So you need to differentiate the xt. Okay, if you differentiate st, what do you get? d over dt of the xt, 2t plus 4, you will get 2 from minus 4 to minus 3. And then negative 2t minus 4, you will get negative 2. This one is from negative 3 to negative 2. And then 2t minus 4, you will get 2 again. 4, 2, 2, 3. And you get negative t minus 8, you get negative 2. This is from 3 to 4. Okay, so if you draw, what is actually this one? From negative 4 to negative 3. So this actually is a unit step. Okay, I just draw it here, unit step in different color. Okay, -4 to -3, I will have +2, and -3 to -2, I will have -2, and 2 to 3, I will have +2, and 3 to 4, I have -2. Okay. Okay, so if I write in term of okay, this one is unit. So definitely from we see that this is the unit step function, right? In the blue color one is a unit step function. Okay, how do you write in unit step function? I can write 2 unit step t plus 4. Okay, t plus 4 minus 2 unit step t plus 3. Okay, and then minus, because it's a -2, so it's a minus 2 unit step t plus 3 minus, so minus minus is you get plus 2 unit step t plus 2, and then plus with +2 unit step function t minus 2 to t minus 3, and then you plus with -2, right? So you have minus 2 unit step t minus 3, negative negative positive, so you have plus 2 unit step t minus 4. Okay, if you simplify it, you will get 2 unit step t plus 4. Okay. This one, you will get -4 unit step t plus 3. And then you have plus 2 unit step t plus 2. And then plus with 2 unit step t minus 2. And then you have this one. So it's -4 unit step 3 minus 3. Plus the last one, 2 unit step t minus 4. Okay. So this is the first order of xt. What if you differentiate again this unit step? What do you get? So differentiate for second order. What do you get? 2 unit step t plus 4. 2 unit step t plus 4, you differentiate, you will get 2, you'll get 2 delta t plus 4. Okay, the time here, t plus 4 or t plus 3, the time here is no change. The change only at the unit step. The Fourier, the differentiation of unit step, you will get delta. That's it. The time is remain. So this is easy. So you have 4 delta t plus 3 plus 2 delta t plus 2 plus 2 delta t minus 2 minus 4 delta t minus 3 plus 2 delta t minus 4. Okay, that's it. Right? Okay, bear in mind that the differentiation of the power of n dt xt is equivalent to j omega power of n x omega, right? So the second order is d power of 2 dt, okay, d prime prime t, okay, equal to j omega square x omega. So j omega is equal to -1. So it changed to negative omega square x omega. So negative omega square x omega is referred to what? is referred to 2, okay, from here, 2 exponent j omega 4 minus 4 exponent j omega 3. Okay, you see that the plus 4 is j omega 4, plus 3 is j omega 3, plus 2 is j omega 2. So you have the constant is 2 exponent j omega 2 plus 2 exponent minus j omega 2 minus 4 exponent minus j omega 3 plus 2 exponent minus j omega 4. Okay, and then we simplify. We have 2. We collect the j omega. Okay, we collect. Okay, say we collect the j omega 4. Okay, we collect the j omega 4 and then minus j omega 4. So we have 2 exponent j omega 4 plus exponent minus j omega 4. And then minus with 4. Now we collect the j omega 3. Oh, okay, I rewrite again. So I have minus 4 exponent j omega 3 plus exponent minus j omega 3. And then plus with, I have j omega 2, right? So 2 exponent j omega 2 plus exponent minus j omega 2. Okay, class, just now I told you already, if you look at this kind of the exponent, you have the kind of Euler formula. So you can change it from the exponent to a cos on the sign. So if you want to have cos, it's definitely you need to divide by 2. Sine is you need to divide by 2j, so it's quite difficult. So you have to change, you can change to the cos. So it's divide by 2. So if you want to divide by 2, you need the 2. So we don't have the 2 here, right? So divide by 2. So you divide by 2. Okay, so to do this, so you times 2 over 2. Okay, you times 2 over 2 so that we remain the same value. We remain the same value for each, but we can change to the cos because we fulfill the form. So 2 times with 2, you have 4. So you have 4 cos 4 omega. Okay, so this part you can change to the cos 4 omega. And then minus with 2 times with 4, we have 8 cos 3 omega plus with 4 cos 2 omega divided by negative omega squared. Okay, where is this omega square from? It's actually from this part. So actually this one is already x omega. I already shift the negative omega square to the right hand side. Okay, so this is the answer. Hope you can understand.